Assalamualaikum and a very good day to our viewers and our lecturer, Encik Hiruizam bin Madhir. My name is Abid Wafi bin Anwar with the number matrix is 01DKM19F1009. Today, we would explain about intercooling, reheat and regeneration gas turbine cycle from our subject, Engineering Plant Technology. Let me introduce our group members. The first is Muhammad Mirza bin Abdullah 01 DKM19 F1010. Next, Nur Aina Atira binti Zawari 01 DKM19 F1011. And lastly, Muhammad Arif Hakimi bin Abu Hasban 01 DKM19 F1012. Overall of our members from DKM 5A. In this video, it contains about 4 topics. The first one is introduction. The second is working principles. The third is a diagrams of figures. And the lastly of this contents are summary and conclusion.
My name is Muhammad Mirza bin Abdullah. My matrix number 01 DKM19F1010. This is introduction for intercooling, reheat and regeneration gas turbine cycle. For intercooling is one of the methods to improve the efficiency of the gas turbine. In the gas turbine, compressor utilize the large amount of work developed by turbine heads. For in this method, multi-compressor are used. For reheat is a common method of increasing the mean temperature of heat reception. Is to reheat the gas after it has expanded in a part of the gas turbine. The last one is regeneration in gas turbine cycle. Regeneration is a thermodynamic process that utilizes the remaining energy in the exhaust gases from the gas turbine to heat the air entering to the gas turbine.
The working principle of intercooling for stage 1 to 2 are compression. The gas was sucked into the compressor and compress it according to the requirement. Stage 2 to 3 are intercooling. The cooling source supplied to the compressed air and decrease its temperature. Next is stage 3 to 4 are also compression. The cooling air being compressed again after intercooling process according to the requirement before it sent it into burner. Then stage 4 to 5 are combustion. At this stage, a heat source supplied to the compressed air and increases its temperature due to the air begin igniting. Stage 5 to 6 are power process. Due to igniting process, the pressure and the temperature of compressed air very high. The high pressure force of the ignited compressed air push the turbine blades. After the turbine blades push, the crankshaft started rotating and the power being generated. During this stage, the air expanded and the pressure reduced. Lastly, stage 6 to 1 are exhaust section. After discharging through the turbine, the gas enters into a heat exchanger, which filters the heated gas and expels the unused heat into the atmosphere. The gas is reintroduced into compressor and the process repeat again. Next is the working principle of reheat. The working principle of reheat for stage 1 to 2 on compressor. The gas was sucked into the compressor and compressed it according to the requirement. Stage 2 to 3 are combustion. At this stage, a heat source supplies heat to the compressed gas and increases its temperature due to that gas starts igniting. Next are stage 3 to 4 are power process high pressure turbine. The high pressure turbine blade was pushed from the high temperature compressed air. the crankshaft started to rotate and the power was generated. Then stage 4 to 5 are reheated. The reduced pressure compressed air were reheated at this stage and increases the power output without increasing the maximum operating temperature. Stage 5 to 6 are power process low pressure turbine. The reheat compressed air pushed the low pressure turbine blades. The crankshaft started to rotate and the power was generated. Lastly, stage 6 to 1 are exhaust section. After discharging through the turbine, the gas enters into a heat exchanger, which filters the heated gas and expels the unused heat into the atmosphere. The gas is introduced into compressor and the process repeats again. Lastly, the working principle of regeneration. The working principle of regeneration for stage 1 to 2 are compressor. The gas was sucked into the compressor and compressed it according to the requirement. Stage 2 to 3 are combustion. It compressed air transferred to the combustor to do the combustion process. After that, stage 3 to 4 are also combustion. At this stage, a heat source supplies heat to the compressed gas and increases its temperature. Due to that, gas starts igniting. Stage 4 to 5 are power process. Due to igniting process, the pressure and temperature of compressed air very high. The high pressure force of the ignited compressed air pushed the turbine blades. After the turbine blades pushed, the crankshaft started rotating and the power being generated. During this stage, the air expanded and the pressure reduced. Then stage 5 to 2 are regenerator. Reheat the air-fuel mixture before it is fed to the combustion chamber. It reduces heat absorbed and heat expelled for the cycle by the same amount. Lastly, stage 5 to 1 are exhaust section. After discharging through the turbine, the gas enters into a heat exchanger, which filters the heated gas and expels the unused heat into the atmosphere. The gas is reintroduced into compressor and the process repeated again.
My name is Muhammad Arif Hakimi bin Abu Hasban. My matrix number is 01DKM1F1012. Then I want to explain the intercooling. Multi-stage compression with intercooling improve the efficiency of a compression process. A Brayton cycle with intercooling uses 2 or more compression stages with 1 or more intercooler, as shown below. The power requirement for compression is reduced, but QH also is increased. Next, reheat. A reheater is a heat exchanger that increases the power output without increasing the maximum operating temperature, but it does not increase the efficiency of the cycle. Next, regeneration. A Brayton cycle with regeneration uses a heat exchanger called a regenerator to preheat the air-fuel mixture before it is fed to the combustion chamber using the turbine influence as the heat source. A regenerator reduces QC and QH for the cycle by the same amount. This has no effect on the power produced, but increases the thermal efficiency of the cycle.
In conclusion, the intercooling, reheat, and regeneration gas turbine cycle are used to recover some of the exhaust heat to improve the thermal efficiency of these respective cycles. And indeed, there will be significant increase in the thermal efficiency of these cycles. The specific work of thermal efficiency can be calculated by using the formula to get the variation. This corresponds nearly to the thermal efficiency achieved by combined cycle power plants. That's it from our group. Thank you.